Hello everybody, I'm Scott Harlow with the Office of Space and Defense Power Systems. We're known as NE75 here at DOE Germantown. And I'm here to present our solicitation for space and defense related activities. So just for a little background, you'll probably recognize this presentation from last year. We really haven't changed what we're doing. We design, develop, build, and deliver radioisotope power systems for space exploration and national security applications. We support research, development, design of fission power systems as well for space exploration and national security needs. We enable science to occur in areas where solar power cannot work for us or battery power is not practical. So radioisotope power systems allows us to go places where ordinary systems really would not function well. In addition to that, our key research and development areas that we want to focus on are developing materials for use in extreme conditions. So this isn't like working in your backyard. This is out in outer space. This is in bad places that power systems would typically have a hard time coping. So our office provides the nuclear power sources for space science and exploration missions and national security applications. We maintain the capability to produce and deliver plutonium-238 powered radioisotope systems. And we report to the Deputy Assistant Secretary for Nuclear Reactor Technologies, that's NE7. His name is John Kelly. And we work with NASA to provide radioisotope power systems for use in space. And we work with NASA to maintain the infrastructure to produce these systems at various national labs. I always put in this slide just to give you an idea. We have been around for a while. A couple years ago, we celebrated our 50th anniversary of atomic energy in space. So we're still at it. You can see, this technology has enabled a lot of capability. So it's really kind of cool to be part of that. And I'm just listing some of our successful missions. You might recognize, I think it's the Voyager one. You will see that on your what do they call that thing? Your passport. There's a photo of this in the first or second page of your passport if you're an American citizen. Okay, one of our recent successes was the Pluto New Horizons mission. And when we started, we could barely see what Pluto looked like. It was just that pixelated view down there in the corner. And these days, we're getting photos back from our probe that are showing just remarkable detail about Pluto. And I encourage you to continue to look at the Pluto New Horizons websites that NASA maintains. NASA has some really good websites, and over time, we're downloading more and more video. Well, they're downloading more and more video that they're uploading, so you can see physically what Pluto looks like. And that's something that this technology has brought to bear. So our other recent success is the Mars Science Laboratory. You probably know it as the Mars Curiosity rover. So you've probably seen some video and photos of that as well. We're really excited. We've got another project called the Mars 2020 that's going to be based on the same multi-mission radioisotope thermoelectric generator as one on this mission. So I'm sure you've seen this before. We use a general purpose heat source as the building block for pretty much all of our systems. This is very well characterized for accident scenarios. We don't want this stuff getting out in the event of an accident, so we make sure that it's well protected for pretty much any postulated accident scenario that we can come up with. And that includes using a lot of graphites and iridium, all very high. I mean, it has, you know, a purpose, and it's all designed really around safety, and then to get the heat out to do the radioisotope thermoelectric generation. So we have enhanced safety performance. We use ceramic fuel, cladding, aeroshell system structural components, and we have very good characterization of anything that we fly on our missions. We're always trying to improve our system performance, including improving the power output, the efficiency, the power conversion, minimizing the mass, increasing the reliability, making sure the reliability is where it needs to be, because once you launch something, you don't get it back. You have to make sure this stuff works the first time. So these are the things that my office worries about. This is what keeps us up at night, to make sure that the NASA missions are well supported and they have a good system when they're ready to fly. And we're always working to enhance our manufacturing processes to increase our worker safety, lower the radiation dose that any workers would be exposed to during fabrication and assembly operations. And we also like to reduce the waste that's generated as a byproduct of any of these activities. So what I'm putting in this year for space reactor and fuels development is we're looking for an effort toward developing a conceptual design for a reactor and a fuel that covers a range of power outputs from 2 to 3 kilowatts electric up to 40 kilowatts electric. So these are this will cover a spectrum of activities that NASA has spoken to us in the past, going from having something that's small and portable, like on a little rover type system, all the way up to a ground support for somebody that would be living on a foreign place like Mars or the moon. It's one of those. So 40 kilowatts was a good power level that we have done studies for NASA in the past, and we think it's still valid. That's about what humans would need. Designs that could benefit both NASA and national security users are sought. I know there are some commonalities, but if we can get something that works for both, that helps with funding streams ultimately when it's time to deploy something. And simplicity of design and manufacturability are important, as well as minimizing the total system mass, especially if you're thinking about a system like this is going to be launched on a rocket, so it's not cheap to launch stuff into space, so we'd like to minimize mass. The innovative design concepts that leverage existing fuel experience that focus on high reliability power conversion and reactor operations. So we would like not to have to go through a new fuels development program if we can use existing fuels that have thousands of hours of proven experience here on Earth. That's money ahead for us. But we are willing to look at novel power conversion systems that improve on the current state of the art. Okay. Another area where we would appreciate some support is in nuclear thermal propulsion systems. Last year I didn't describe it very well. This year I made sure I got the guy to describe it a little bit better, what we were after. And we would like a nuclear thermal propulsion system design that would use the NERVA-derived composite fuels with performance goals of 25,000 to 30,000 pounds of thrust with a specific impulse of 900 seconds. So hopefully that'll answer the questions about what exactly we're looking for. We'd appreciate it if you could attempt to leverage the existing NERVA fuel and reactor designs to optimize the proposed propulsion system designs. And then finally, This is one of the things that I'm always looking for is a portable terrestrial reactor. I know there are folks in the defense community that already have something similar to this. I was thinking of something that was a little bit smaller. So from 100 kilowatts to 1 megawatt of electric power output. It would be great to have this thing self-contained. So think of it as something that could run on the back of a truck, so that it can be deployed and at the end of its mission be removed. So there you go. Let me know if you have any questions.
Are you interested in computational work for space reactor designs?
I don't think this year we're after that so much. We're looking more for actual physical designs.
What is the expected funding level for this program?
That's a good question. Do I know that answer?
The proposals can be up to $400,000.
Go for the limit, 400K.
What lifetime are you considering for the portable terrestrial reactor?
So when we were doing a space reactor design, we were looking for an 8-year life. I would think a portable terrestrial reactor would probably have a rougher life, probably a 5-year design. I'm just guessing on that, really.
Does the proposal need to cover both the fuel design and energy conversion systems?
It does not.
There's a question that's probably unanswerable at this point, but how many awards do you expect in this area?
Well, I just want to let people know that this is my 3rd year of doing these presentations. We have made awards in each of the past 2 years. So don't assume just because this is some wacky technology that's far out there that an award won't be made, because depending on the quality of your submission, you very well could win.
Is UN considered a developed fuel by your definition?
Uranium nitride? Yeah, I think it is. I think it is. Not quite like an oxide form, but people are aware of its characteristics.